Hello and welcome to a new video lecture. In this lecture we are going to understand pulse width modulations and how to implement it using Arduino API. Let's get started. In simple words, pulse width modulation is a technique that allows to write analog signal from digital pin, and this technique allows us to get different resolutions and levels of voltage depending on the shape of the wave generated. So on the screen right now you can see different shapes of the wave that is being generated. At the top of the graph we can see, and when there is a 0% duty cycle we obtain 0 volt. This can be obtained using Arduino API method analogWrite and pass the value 0. That means we are not passing any current on the pin. Of course, to be more specific, analogWrite takes two parameters. The first parameter is the pin we are writing to, and the second parameter is the value we are writing. But for the sake of simplicity, this graph focuses only on the value that is to be written. Then on the second row, we can see that we have increased the duty cycle to obtain 25% duty cycle. In this case, on volt range between 0 voltage and 5 voltage, we would obtain 25% of the 5 volt, that is 1.25 voltage. Of course, depending on the analog reference set on your Arduino board, you should know first which is the target value for the high signal, because as we have discussed in a previous video lecture, the target signal could be 3.3 voltage or 5 voltage, and you can also check that using analog reference pin, or simply read the datasheet. The third row, we can see that we have increased the duty cycle once again to 50%. This can be obtained by using the API method analogWrite and pass the value 127 or 2 power 7. And we can see how the waveform generated has changed to be 50% of the time on the high voltage level, and then the step function drops for the rest of the 50% of the time to be at a 0 level. The same with the 75%, and at this time we are using 191 as the value for analogWrite method, and we obtain 75% of the 5 voltage, which is somewhere around 3.5 voltage. Finally, we obtain 100% duty cycle when we write 255, or that's 2 power 8, and we can see here we are not obtaining a step function anymore, but instead a constant voltage flowing on the pin at the level of 5 voltage. This graph makes it very illustrative to understand the pulse width modulation. But what's the intuition behind pulse width modulation? The idea is that usually when we connect a LED, a motor, or a stepper motor, we connect capacitors and resistors to control the amount of voltage and the current that drive the LED or the motor. I'm talking about DC motors. However, connecting resistors directly in their circuit for this purpose can dissipate the energy and also increase the heat of the circuit. Another idea that avoids this trouble is to use a signal to drive the LED or the DC motor. And the idea is that alternates between on and off. Then you will get an average of the total signal. For example, if you drive a wave that's on for 25% of the time and off for the rest of the time, you will get 1.25 voltage in case of 5 voltage high level standard. Another intuition behind pulse width modulation is that it allows digital pins to emulate analog outputs. So to wrap it up, pulse width modulation is a method for waveform generation, and it depends on the amount of time the signal is on or off to decide the driving voltage that is being available on the output pin. This can be done using analogWrite method from Arduino API. Finally, let's make a distinction that analogWrite method has nothing to do with the analog pins on the Arduino board. Let's see why. For this exercise, we need to implement the following circuit. We've got our Arduino board. You can see here I have connected a signal pin to the analog 0 pin at the bottom right of the screen, and another ground pin, and connected both of them to a LED. You can see a LED is a light emitting diode, and it has got two pins. One is positive named anode and the other is negative named cathode. Usually manufacturers make the positive pin much longer than the negative one, but always check what you have got. So we connected the positive pin, the anode, to the analog 0 pin of the Arduino, and the negative pin, the cathode, to the ground pin of the Arduino. And again I've got another LED and I've connected it to pins 11 and ground on the other side of the Arduino on the line of the digital pins. So on the screen you can see where I'm pointing the cursor over here. You can see that the tilde notation stands for pulse width modulation, so only the pins 3, 5, 6, 9, 10, 11 support pulse width modulation, and this is exposed through the method analogWrite. Even though the method is named analogWrite, it has nothing to do with analogRead or the analog N, where I'm pointing with the cursor at the moment, of the 6 analog pins on the bottom right of the screen. So this distinction confuses some people most of the time, but be aware of that. The idea here is very simple. I've got two LEDs connected to the Arduino Uno, and we would like to see if we write a signal using analogWrite to both of the LEDs, how much difference is going to make when we use pulse width modulation and we use regular analog current. So it is a thought experiment where you design a circuit only to observe the results and understand the difference between the functionality. I have found this to be a very efficient way to teach you how to see the difference between pulse width modulation digital output and analog output. As an exercise, you can try the same setup with the other digital pins like 7, 8, 12 or 13 and report the difference and share it with your colleagues in the forum associated with this course. Let's move to the coding part. The code for this exercise is very simple. What we do is we write down analogWrite A0 to 55. Let's start with 0, 0, analogWrite pin 11, 0. Let's save the file, upload it, and now I will use my own voltmeter. A voltmeter is a way to measure the current, the voltage and the resistance in your circuits. It's a must-have tool in case if you want to play around with microcontrollers and circuit design robotics in the future. So I will use the ground pin, connect it with the ground pin of the LED, and I use the voltage pin or the high voltage pin of the voltmeter and connect it to the A0 pin of the Arduino board where I've got the LED connected, and I will measure the voltage, and I will do the same for the other LED connected to the pin 11. At this point the voltage should read 0 on both sides, since we are not driving any current or voltage on these pins so far. And now let's do the experiment this way. We'll increase the 0 to 32, 64, 128 and finally 255. So now I should increase it to 32. Over here I've got it to 32. And let's measure with the voltmeter the reading on the two LEDs. And then let's increase it to 64 and let's measure the voltage difference on the two pins of the LEDs. Then 128, and let's measure again, 255, and let's measure once again. So the question now, why have not exceeded or gone beyond 255? This is called the resolution of the analogWrite or the pulse width modulation. This is a value preset on Arduino between 0 and 255. That's between 2 power 8. If you'd like to know more about these internal details, you can use the analog reference bin description and also use the analog reference method from the APIs to set this value on Arduino at Mega, not on Uno, and some other versions of Arduino, but specifically this feature is not allowed on Arduino Uno. And then we've got another method that's analog reference resolution or analogWrite resolution. AnalogWrite resolution allows you to set the resolution, and analog reference allows you to set analog reference the high voltage, whether it is 3.3, 2.5 or 5 voltage, depends on your design, and so on. I have attached course material for this lecture, a set of references to read more about pulse width modulation and analogWrite, analog reference and analogWrite resolution. Thank you and see you in the next lecture.